Hello and welcome to the Environmental Test and Design webinar, Reports, Conveying the Message for MIL Standard 810G. My name is Belinda Stashikevich and I'm the editor of Environmental Test and Design. Environmental Test and Design, which launched in 2009, specializes in the interrelationship between electronic systems and devices and their environments. This webinar is presented by Steve Ferguson, Executive Vice President of Washington Laboratories. Steve has worked in the compliance test arena for over 35 years at test labs and manufacturing companies, designing products, developing procedures, and performing tests. He presents various courses on EMI and EMC compliance, and he is an INARTE certified EMC engineer and administers the INARTE-approved Washington Laboratories Testing Center. To watch any of our other webinars, visit www.environmentaltestanddesign.com. This webinar is the fourth of 4. This webinar will be interactive. You'll be able to ask questions and answer polls, and we encourage you to participate. Take a look at your GoToWebinar navigation pane. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand to ask a question or report an issue, click the hand icon. We'll present the topic for 45 minutes, followed by a 15-minute question and answer session. Before we begin, we have a poll for our audience. Do you prepare test reports, review contractor reports, approve reports, or other? We'll give you a few seconds to answer. We have some answers coming in. Looks like about a third review contractor reports. Wait, more people are voting? About half prepare test reports, with a few more review contractor reports and approve reports, and a few people said other. Over to you, Steve.
Well, very good. Thanks, Belinda. Good afternoon to all, or wherever you are. Good afternoon, morning, evening, etc. I just wanted to kind of get a feel for, where the audience is, but preparing reports is a good portion, and that's what this focus is. Remember that this webinar series started in the spring with us taking an RFQ and bringing it through the planning stages, developing the quote, pricing it, doing the testing, and now we're preparing the reports. But an interesting thing happened in the midst of doing all this. 810 Change 1 got issued in April of 2014. And I'm hijacking my report presentation here to add this feature into the discussion, because one of the things that it states is tailoring is essential. It's no longer clearly defined what the test program is, or even very closely defined what the test program is. Where we used to be able to say, well, let's do a vibration test, and there was enough information to get you a long ways, or do a temperature profile, or etc. With Change 1, the requirement says you've got to tailor the project. Each one of the test methods except 528, and that's a well-defined shipboard vibration test. But the other things are saying, let us concern ourselves with the application and etc. And the Part 1 puts a lot of guidance on this tailoring in the Change 1 issue. So the methods are not to be called out in a blanket fashion, nor applied with unalterable routines. Those are statements right out of this Change 1 standard that's an update. So we're seeing a more ill-defined test, shall we say, or not specified. And this brings into some considerations that all of the manufacturers, or whoever's getting the testing done, needs to be very aware of. The Change 1 does provide a lot of additional environmental data to aid in the tailoring process. We got over 1,000 pages of a document now. So, but now the implications are occurring is that we need to have a better understanding of the application. We in a test lab here, we frequently get requests that come in that say we'd like to do environmental testing per 810, and that's about it, or figure out the application, or I'm going to do X, Y, or Z test methods, and it's the guidance we get. So without having some sort of tailoring information, it's very difficult to know what we're doing. Also, widespread applications that use the tailoring, you have to define a worst case event. So if I'm a manufacturer who says, well, I need to get an approval, but I'm not a contract funded item, then I've got to figure out what I'm going to do. Where's my application? Is the Navy going to use it? Is the Army going to use it? Is it ground or seaboard, etc.? And so this brings in the difficulty of understanding what worst case may be for your particular kind of product. Also, the things that show compliance. This item complies with MIL Standard 810G. That diverse meaning really comes about now. That what portion of it, what tailoring happened, etc. So these slick sheets or advertising brochures that says complies with MIL Standard 810 have a lot of ambiguity. So without having more understanding of what's there, then that statement becomes less meaningful to purchasers or those people looking for that. So we have to look at how this can happen. And also, there's a lot more rigorous planning necessary. It's no longer, let's just do the test and throw it to the wind. You've got to figure out where this is going, because now the tailoring is not always clearly defined that a temperature profile is the one that the reviewer or the person approving the test report agrees that that's the correct one for the application. So it really takes a lot of work to come up with the planning efforts. So I think particularly for the labs, we're going to be challenged much harder in getting definition from the manufacturer or the person that's contracting us to do the test work. A lot more interaction will go into the front end of this item. So like I said, I needed to bring this up and wanted to do that as an introductory thing, because during this I'll be bringing some more elements about this change one through this presentation. But again, if you've not downloaded it, you have the assist.dla.mil website that's available. So anybody that doesn't know that one for the MIL standards needs to find out what that is, and you can contact me to get that link. So, but let's look back to the data item description. We normally see these data item descriptions that detail what a report or a plan or whatever documentation is associated must contain. The MIL 810 is not calling for one except for shipboard vibe, where method 528 specifies a particular data item, and it's 81647 for the plan and the report. Both are covered in one data item, and it involves the definitely shipboard vibration work, including field trials, the shipboard, documentation on the hull of the ship, what class, lots of things go into the detail for this particular aspect. This is also linked out of 810 because it calls for MIL Standard 167A. So it switches from the 810 gamut into the 167A, but it's still called out in 810 as giving a lot of detail requirements, etc. So 810 gets called out and it defers over to the other standard. Content is very much specified with the format being open. And again, format open drives me crazy. The contractor format is allowed, but without some sort of definition and organization, reviewers often have trouble figuring out where things are being reported, what the details are. So they look at it and says, well, if it's not organized well, then they don't find the information and you get a disapproval notice because you didn't report X and it was there, it just didn't come out in the way they said it. So I really prefer seeing some sort of data item, an outline that says do these things in this order. And so those are topics that you need to consider. Can we use that DI for tests other than ship vibration? Well, some of the elements may apply, but other things are not really there. And also it doesn't allow this tailoring. So what I'm suggesting is I'm going to outline a test report, whether it's a DI or anything else. And by the way, my particular test report outline kind of follows the EMC world, where a very well-defined data item description is is present. So I use the generic kind of philosophy, but tailor it out for an environmental test program. I've got another question here, Belinda.
We have another poll. Attendees, please answer the following
Yes, it's
question.
on the screen.
Do you have or use test report templates? Yes. Established for each test. Yes. Generic with content defined. No. Reports are generated by contracted test facilities. Or no. Not involved in reporting. We'll give you a few seconds to answer. And it looks about pretty evenly distributed between A, B, and C. Back to you, Steve.
Well, the C, or the 3, is kind of a trick answer, because what I'd like to see is that these reports generated by the contract facilities, if you're defining the content and requirements to them, then they will follow that guide. Or at least you should try to find an outline that they're going to be using so you know what your report's going to look like. This is particularly present when you have organized test procedures and etc. that have been approved. I like to consider that if a test procedure plan is provided, that there's an outline of the report being established in there. This is what we're going to do for reporting. So everybody gets on board at the very beginning of the test program. Let's think about the report outline. Prior to reporting, we need to think about the report. That must be part of the testing, because without it, you don't collect the data necessary to support this document. You won't have the charts, the graphs, the tables, the data points, the etc., the photographs. Do we need to consider all those elements in the very beginning of the test to say, I'm going to need these things at the end, so therefore make sure we collect as we go through this process. So the test execution is really a function of what we have to do with the report. What information is there, where the failures are, where the modifications are, etc. We need to look at a frontispiece or an abstract, something at the very beginning that says, generically, this is what's happened. Administrative area. We need to define our test article, our EUT, equipment under test. We need to rehash the requirements. And we need to consider deviations block. I'm just getting through these because we're going to speak to each one of them. We need to have a results summary that's linked into the detailed results. So fundamentally, we're setting up something for the reviewer that is not technical, and to say this is the bottom line, very short kind of information that clearly gives us the details about the project without all that measurement stuff. And then the measurement stuff supports all those activities. It follows through. So we're just going to go through down my idea of this report. The frontispiece, or the abstract, shall we say, gives us what's the report covering. This report is to qualify XYZ for customer X, and it covers the mill standard requirements. And then we look at the requirements summary, where these requirements are there. Each one of the methods done should be tabularized, put into a table with a compliance statement. Did it comply or not comply? Pass, fail, whatever you want to say there. And some sort of explanation about what we did, whether we did a temperature test and we tailored it for X, Y, or Z. This is kind of like a target for a single page or a couple of pages of data that gives you the bottom line. This is it. Also in this area, you need to consider revision history. Very few of us get away with the initial issue being the final report. There's always some questions, typos that do happen, things like that involve every document virtually. And we need to be able to track when what happened and why we're doing the change. Hopefully we don't have many of those changes. The administrative area of the report provides a scope statement again, much like you had in the abstract, and the test specimen identification. What did we test? Let's define it. What board set is in it? Are there a set of boards? What revision levels? Did we look at this thing? Sometimes these defer into the manufacturer identifying this list so it is qualified by a drawing reference or something. But we definitely need to identify what we did. Test article XYZ, serial number Y, and the build configuration if it's appropriate, something to talk about what we had here. So it's not left to chance that is in question. We need to go again with the requirements summary. Basically, that frontispiece table gets pulled back in, put into the main body of the report. A lot of people will skip over things like abstracts, etc. So this is your going in position. These are the things that did happen. Let's identify the test dates and locations, where these things are going on, and consider a link. The link I'm referring to is here maybe as a hot link within the document to take you to the detailed paragraph or to something along that line. So I can click on this spot and go to the details about any particular subject matter that I have concerns about. Pull in our references. What does the contract happen? The standards, any plans or procedures that were approved. We need to consider those elements to firmly identify what this is all about. The contract can be a lot of things, and sometimes the test laboratories put in the contract from their customer. The customer may have the ultimate contract that says I'm supplying under the Navy contract XYZ, so test lab, please provide this into the information also. Some customers of the test lab have their own cover letter that says this is related to contract X, but it's real convenient to have this embodied within the document. So ask your customer, do you need other things other than just the contract or PO number you issued or what reference it is? The standards that are applicable, if we're calling in 810 and it happens to be a Navy ship, 167 can also come into play, or whatever the 810 points to. Plans and procedures that are approved become the document that you're referencing to. Once those procedures are approved, they became the standard for that particular project. Look at the contacts. Who did what? Who's associated with what things? Where do we reach out to people with a question? Who did the project? We may not need to know that within the first 30 days, but 6 months, a year later, when a question arises, where did this really happen? List the abbreviations. We often forget that we use acronyms liberally without defining them. Today's writers are used to everybody knowing every abbreviation in the world or being able to assume this. From our online work to abbreviations in our texting and etc., we've developed this habit. It's not a good writing technique. Abbreviations and acronyms need to be well established, define what they mean in this document, and be consistent with what you use in the abbreviations. The autocorrect drives everybody crazy when they try to put a small k in and it puts it into a capital letter. Well, a small k means kilo, a big K means Kelvin. Quite a bit of difference between the two items. So we need to define what they are. Sometimes you can have multiple meanings for the same acronym. And so be cautious that you cover every one of them that's used within your document. Having this list is very good. And I notice a lot of people use common acronyms and abbreviations that they use virtually all the time and put those in an abbreviation table. And then let the others that are rarely used stand on their own without being in the table. That's acceptable. If you can pull them all back in, it's preferred, but an acceptable method is get these common things well defined so there's a clean reference point. Remember, just because you understand all the environmental acronyms doesn't mean not every reader understands that. So be consistent. By the way, if you're going international with these things, that becomes even more of a dominant because we all know that FCC means Federal Communication Commission, except when you're in another country, and it can take on a whole new aspect. What was tested? We need to get that information is there. What is the build status? Did we do a prototype, a breadboard, a production article? Did it represent production? What operational modes are evaluated? This becomes real tough to do that. Like for instance, a radio transmitter is entirely different on temperature work when there's power being dealt with in a transmit mode versus it sitting there in receive mode listening for activity. You may need to do two different tests here, one for each mode, and that clearly needs to be defined going in, or do we sit there and do it and operate it during a duty cycle and say these are the worst case events? Can these things become different depending on the test? An operational mode for vibration may be something entirely different than when I do climatic or temperature work. What support equipment did it take to make this thing work? And how was it isolated or segregated from the actual test article? What did we do to support it? Basically, you're writing something that says this is what we tested and these are all the things involved with it. So a year later we can recreate that if the need would come about. What about storage tests? Did we include the packaging information? Was packaging a part of storage, or is this an open storage thing? Transportation, transient cases, the like. Did we use them? What were they about? What model of that was dealt with? Quite often we forget those pieces. We well define our open test article and all the card set and etc., serial numbers, bill status, etc., and then forget all the other things that we evaluated as part of the program if it comes into place. The test configuration needs to be very clear. What kind of cables? How many? When you have a cable attached to a unit and it's on the vibration table, 25 cables change things differently than one sample cable. You need to consider those things. Mounts. How did I get this thing constructed? Did I have a heat sink accidentally created that caused the temperature to change? Did I do things like that? Does the mount represent an installed kind of configuration? We shouldn't ignore these things. And how was the mount integrated? Did we have shock mounts? Did we have anything going on here? So let's define our configuration. Be clean about this definition. And sometimes this may not fit in this area of the report. You might have a standard configuration and then refer to each detail for specific mounting instructions and details about it. Mechanical loads. What would we do to support this thing? Well, was it loaded? Should it be loaded? Those things are defined in the procedure, but in the absence of a procedure, you need to see how this worked. Define what they were. Was I pumping water or air through a liquid pump? Pumping air does not put on the same sort of mechanical load that pumping water if it's a liquid pump. Things of this nature should be well defined. Let's continue with the EUT information. The modifications that you accomplished. What was the purpose in the mod? I put in a new rubber gasket to take care of a leak test that was discovered during immersion testing. Okay, well that's great. The testing that was done with or without the modifications. Well, if you reserved the immersion test till the very end and it failed, which tests need to be recreated? Would climatic testing, hot, cold, still be acceptable? That we had to redo the modification that says we had to use a new gasket material, and so all we do is redo the immersion? Probably not a satisfactory answer. So that's part of these things that you have to define going in. What kind of acceptance criteria did you use? Was an operational verification being used? Where are the records of these operational verification tests? Did you have to make measurements during the operational verification? Where's the data sheets for that? Did you record data for the verification? Well, if you didn't, you should be. And reports should have those data sheets. If you scan them, electronically create them, whatever, they become part of the report. That you measured 43, and then the next time after the next test, you measured 42.9. How much was the deviation? What did we see a trend going on as we progressed through this test? By the way, an operational verification data sheet should have what you're verifying, identification of the test article, dates, when did what happen, who did it, get some signatures on this thing, at least identify who's preparing these things. Any inspection criteria? Did you document what you did for inspection? If the report says examine and there was no changes in the inspected area, what did you inspect? Did you look for leaks, cracks, holes, corrosion, whatever? So these details need to be defined clearly instead of just a general acceptance, no errors, because that becomes our default kind of thing. And by the way, what happened to the test article? Did you throw it away, set fire to it? It was destroyed during test? The manufacturer took it back and made sure nobody could find it? You know, I don't know. What did you do with it? As a test lab, you're writing, I sent it to X. Possibly the manufacturer wants to have that also to where their disposition is included. So things like this should be considered in the reports. Requirements. A lot of times the tests performed are just simply a reference to that test results summary, that sheet that says these methods and their pass, fail, etc. Test instrumentation. Most refer to a list that's within each of the test method results. In the test methods, you need to define what instruments were involved, and especially anything that affected measurements, the calibration standards. What calibration standards were in play here? Did you have your list of the detailed records for the calibration? You may not include, hundreds of pages of detailed information, but where are those detailed records maintained? Most of the time they're maintained at the test laboratory, and they hold these records for an extremely long time. Most record-keeping places go into the 10+ years. Unless you deal with nuclear power or nuclear anything, then you got a 30-year retention need for a lot of these documents. So if your records aren't available for an extended period, you're shortchanging and you're subject to an issue if this comes back. What was the acceptance criteria? Most refer to the results summary to say that the pass-fail was, well, the measurement stayed within 10% or whatever the acceptance criteria was to get that ultimate pass, fail, complies, not complies, etc. And again, in the requirements, refer to the test plan and procedure. When you refer to these test plan and procedure, you shouldn't be having somebody chase one down, another document that's somewhere else, been filed a year earlier when the test procedure got approved, and we're finally getting this thing down. That test procedure should be an appendix to the report, readily available. Any deviations or tailoring? Deviations to the test plan or standard needs to be identified. What did I do differently than I planned to do? Why did we do it? Why did we make this change? And what's the reason? Who approved it? How did we get the approval process? I went through an episode recently of sending these letters and an email to customer, to the government agency for the approval of the deviation before we were allowed to proceed. So every time a deviation was needed, we almost had to dead stop the work before we could go. Now, these things occur all the time because of minor little items, like something didn't quite fit and we had to bore the hole to get the mounting bracket to set right. That's a deviation in some cases. Some people ignore that kind of thing because it's just a non-issue. Sometimes programs are so closely monitored you need that record of the change. When they come into this tailoring process, remember change 1 of 810 specifically stated to include the technical rationale for tailoring in the report. Well, it's the right place, sure, but you should have done this before the report ever got generated. If you were supposed to run a temperature profile for a humidity, a cyclic profile, or an aggravated profile, and the tailoring would call for it to be at a higher level because of a particular location, and you didn't get this pre-approved, you go off and run the test, the reviewer says, wait a minute, it shouldn't have been done with a max temperature of 71, it should have been a max temperature of 85 because this goes in the engine compartment of the vehicle. So suddenly your report is identifying a flaw in the tailoring that the end user says this is not acceptable, so you go back to square one. This tailoring needs to happen during the planning phase. Any of these elements should be considered to get this right, and we simply convey that forward into the rationale being in the test procedure, and you refer to it in the test report. Get this early. It's just the whole program goes awry if you depend on the end result to be satisfactory to all reviewers. Sometimes this tailoring can lead also into the opinion-based element, where it's not really supported, but in the opinion of the approving authority, they want to see this versus that, and they have a reason, and it's hard to negate that reasoning. So look out for those kind of issues as you go through the process. Linda, I have another poll question open.
Okay, we'd like to ask the attendees, where should tailoring rationale be presented? Deviation or tailoring select section, as part of detailed results, maintain and test plan with reference and report, or do you have no opinion? I'll give you a few seconds to answer. And looks like about half said maintained and test plan with reference and report. And second probably would be the deviation tailoring section, followed by as part of detailed results.
Well, good. The test plan's got to do this. No matter how we get it there, the plan has to deal with this tailoring section somehow. Even if we're planning it on the fly, that here we got it mounted on the vibration table and then we need to adjust a profile or whatever, we're still planning. And getting this documented is a difficult task. We're all part of the reporting process, whether we know it or not. The person operating the vibration table is part of the reporting process because they're feeding data into that report. They've got to be a party to it, understand what the goals are, what the targets are. Remember pictures. You can throw away a bunch of pictures in our digital age, but you can't get them later. So consider those things well into the program. What does the pictures need to see? We'll get into that. So let's talk about our test results summary. This is that first section in the detailed test results where we just put a recap in. That list that we had in the administrative summary of the report, copy that table and put it into here. Keep that compliance statement and definitely use the links here to the detailed results for each of the methods. If you have a link to a heading paragraph on each one of the methods, you can click on it and go straight to that area. List the test sequence. What order of testing would happen? Now I see a lot of documents that I've looked at over the years that list the test sequence, and they have a number or they depend on you to look at the date of the testing to know the sequence. Well, the idea is that they link them into the order of their method, like 500 comes before 501, so they use that organization. Some list them in the order they were done. Some list them in a variety of ways. The idea is you need to figure out what that is. I always like to list these things in the test sequence, so even though they're out of order numerically by the method, the test sequence is clearly defined and they're placed into the report in that order. Well, man, that looks ugly because it's very hard to set up a template that's got all the various elements in. It says, okay, I've got a template for method 500, and then I've got a method for method 501, and a method 502, and a method 503, etc. Then I get rid of the ones that don't apply so they're still in the order that they appear. Guess what? I'm going to use that method. I'm going to keep those, and then I'm going to put a numeric, this was tested in this order in the table. No matter what order they appear in the summary, that's why the link can get you anywhere, no matter where the organization is. All of us need these report templates with preset criteria that's got open items to be filled in particular to the item, so we don't forget to include the details about that item. Our templates should have this outline and a placeholder that says you got to replace the placeholder, whatever it is, the TBD, with the information. But we still need to look at this test sequence because this happens with the test with and without modifications. For instance, that example we used where immersion caused the gasket to change, So we went back and redid a hot and cold cycling event before we redid the immersion. So that test sequence would have that method hot and cold appearing twice, at the very beginning, and then it'll show up again near the end where the retest was done. Both those tests can be dealt with in the test results summary because a lot of the same information is there, and we just restate the results. The first results were satisfactory, and the second results that came about because we had to make a component change shows up, and they were satisfactory also. So the end results can be the present. Your documentation should show the data for both tests, so that was there. And again, you let this summary serve as introduction to the detailed results. You're just opening the door up for the detailed discussion. The detailed results should occur, and this is for each one of the methods. So if I've got a method 500, we're dealing with that, and then 501, 502, etc. In a lot of cases, things are combined, especially like climatic tests where a hot test 501 and a cold test 502 are done as a sequenced event through one program. Some people report these results as that because their chart shows the overall profile being followed. I don't object to that, just simply you need to state that's what it's about. Your titles and headings need to so state. Summarize the requirements again for that. What were we trying to do? What was the acceptance criteria? It should should maintain operation at this level of performance while it's under temperature extremes, the operation. What conditions were involved? Environmental conditions, that is. If I'm in a temperature chamber, I'm controlling those environmental conditions, so that's not really a pertinent issue. Well, what about vibration or acoustic testing or something else where the environment can have an influence on your measurements? For instance, an acoustic test accomplished in an outdoor environment. Can road noises and etc. in the area cause things to occur? Personnel involved. Who did this and when did we do it? And these can be both for the retest and for the primary test. Provide a summary of the procedures. Recap what you did do. I'm not looking for the whole test procedure and all of its glory that's in the detailed procedure, but a summary. We did these things in this order. List your test equipment with its calibration date, and also discuss any equipment checks you did during the test. Did I need to check that the sensor was measuring correct? Did I need to do a resistance measurement for a load circuit to see that the load was in fact correct? The results are present with the details. Discuss the results. What was the results of this? Just don't say worked good, lasted a long time, it's okay. Discuss what we did. We got the results that inspection showed no fractures, deviations, no corrosion, etc., whatever the detail is about that. You need to point to the tables and figures and charts and graphs and pictures and etc. and discuss what is being indicated on those things. In this results section, the results should say see figure X for the test configuration and Y for the accelerometer location. That's what you're trying to say. This is what you're pointing to here. So discuss why are you sending them to see the chart? See the chart for the detailed vibration results. Notice the legend shows that the control accelerometer was X. Things like this can go into your detailed discussion. Why are you sending them to see anything? Point out the specific information being shown. Especially prominent if you've got things that are ugly. Things that show like this thing got out of control. Well, why did it get out of control? For instance, I've got a temperature profile and I saw a 10-degree spike had happened. Or a 10-degree, a spike happened. Well, the spike happened because I had to open the door because of a problem. It didn't affect the base temperature. However, you'll see the spike on the graph because the sensor picked it up very quickly. Explain why you're showing these things. Let's continue the charts and graphs. They provide a good visual presentation of the measurements. The resolution, the scale needs to allow for the tolerance visibility. Now, the example I'm showing here shows a test procedure of what we plan to do. You'll notice that I've inset a table, so all of the various points are identified more distinctly. I shouldn't rely on that chart to give them that detail, 34.6. The measurement units are shown in here, so I inset the table to provide that information. Again, the table in the report area provides detailed data. What were the things of concern here? What were my measurements? Again, don't try to overwhelm it with quantity. Don't put in a 25-page table of every measurement point there. Look at things that are pertinent. Take this thing apart. The chart tells you a lot of things. The tables tell you the specific details on the maximum temperature, the null point, the crossover point, things like this. If you use these tables inset into the charts to highlight certain points, it provides for a very good presentation. Remember, presentation is the only thing this reviewer is going to see. So if you're not paying attention to it, you leave them wondering what's going on. And if they wonder, they start asking. Answer the questions that you may see coming up. Again, the detailed results. Plan the photos. You can't just do this. It's not an image of the test. In the example I show here, that this is the location of a control accelerometer. Now this is one of two pictures. The picture could be of the whole test setup and then a focus picture of that accelerometer location. And notice that this indicator, the control accelerometer location, as I show here, could be in the report. This is distinctly pointing to what you're trying to tell them. The close-up views to show these points are clearly there. The overlay pointers, you put the arrow in to draw attention. And by the way, you can use a lot of arrows. Duplicate the photos. One image shows two test methods, then use the same image twice. Sometimes we'll say that the 501 hot temperature and cold temperature had the same configuration in the chamber. Happens all the time. Why should somebody that's reading the cold area have to go back to the hot area to look at the photograph of the setup? It's easy to clone it, just put it in, it's with the data. How about videos? Is that a viable test reporting method? Could we consider it? And how do you plan for that? With the videos, not knowing whether you're going to need it or not, and you see something going on, well, you'd have trouble getting it. I got an example here I want to play. It's quite an example there. Hopefully everybody enjoyed that. But without the planning for the video, you don't get to do that twice, because obviously the same results are not going to ever show up again, because they're going to have to rebuild everything. That video into a report or a link to a video that you provide, is, if somebody wants to see it, provides a lot of information about what was happening here. So the idea is, and I'm going to go back to the previous, not just photos, but these videos can be a very useful tool. But as I said in the very beginning, you got to plan for them. And without having the planning in place, you're not going to capture the event. So consider these elements as you go into the items. Quite often we don't see a need for this, but there are times when suddenly we're surprised. I remember the day when a unit went up in smoke on the vibe table. You don't get another shot at that one either, and there was no video for that one. Be a lovely thing to have. So with that, you need to consider answering the questions before they're asked. If you include information to support the data points that are not easily understood, and explaining those glitches, why did that spike happen? Why did this happen? Do you have an answer for it? If you can't explain these things, then who's going to? Because the question will come up. You might as well plan for it and try to have it in there. Get an internal review process. Have somebody else read this document before it goes out the door. you cannot see minor errors. You're way too close to the subject. You knew what you said. No matter what you said, you knew this is what you intended to say, and that's the way you'll read it over and over again. If the reviewer asks a question, then the reader may have the same question. Consider questions from the reviewer very readily. Don't take it as explaining it to the reviewer. Discuss it and say, do I need to consider putting more information in so that question does not arise? Check to see that you've included the information specified by the contract, the standard, or the plan. If it says you're to enter the specific gravity of the water during a rain test, well, then that information should be in the report. It shouldn't be left to have the final reviewer say, where's this information? And you go look rifling through all your files and say, oops, forgot to measure that. And that was clearly in the plan that said we're going to report that. So look at these plans, document standards. What reporting requirements are established? Make sure your report has a place to answer those questions and get that information. Airspeed, loads, pressure, lots of things. And again, make this test plan or procedure an appendix to your document. You can't get these things later. A good report goes in front of the reviewer, their confidence goes sky high. Your credibility goes sky high. And the minute one question is asked, it opens the doors for repeated questions. And suddenly the wordsmithing starts to occur. So the idea is that if you've been very thorough and detailed, somebody else can review it and understand. He closed all the doors. Again, don't hesitate to have that reviewer. It's one of our policies here, and we take that very seriously. We're looking to see the gotchas. Do we get it always perfect? Oh no, you can't spend enough time for perfect, but you sure can make an effort to get rid of the bogus, the detailed stuff that drives you crazy. In general, with documents, make sure you convey the message. Discuss it in terms that the reader's going to understand. Remember, you may be talking to someone that's a product developer and can't spell environmental 3 out of 5 times. You've got to understand the topic to them. Remember, procedures are for engineers and technicians. Be thorough. Make deviations obvious. These reports are also needed to be for the engineers and technicians and those people that have the final approval. Was an adequate evaluation done? They didn't see you do it. You just got to document it to the point where it's there. Be very thorough. Put some specific details in. And don't hide those deviations. Make them obvious. If you can't justify a deviation, then you shouldn't have done it. Be complete without being too wordy. Get to pertinent information. Don't bore people to death. Make sure the reviewer and approving authority can determine acceptability. Did you get it right? Use figures, pictures, charts as we discussed. Pictures with a killer word. Requirements specific for the individual test methods need to be rehashed. We need to take care of that. And particularly in the technical rationale, justify your choices for tailoring. Change 1 requires it. It's not an option anymore. You've got to support your data. And why did you choose to do what you're doing? It's no longer an element of, I chose to do this. Well, what caused you to choose that? What environmental profile data did you refer to? I've got a worldwide temperature chart. I use the worst case. Whatever your rationale is, this is the place to put it. This concludes this presentation. The 2014 series is done, the 4 topics that we planned. Be on the lookout for future presentations. And let us know about specific topics, something you'd like to see done. Your input is truly valued. Linda, did you have anything to add?
Great, thank you, Steve. We'd like to have a call for final questions from our attendees. Please enter any last questions you may have in the navigation pane at this time. We have received quite a few inquiries on where to get additional information on this topic. There's a vast amount of content on our website, environmentaltestanddesign.com, or you can email us at info@etdnews.com with specific needs, and we can direct you accordingly. Steve, here's a question for you. When does change 1 become effective regarding the requiring the tailoring?
Well, it was issued, I believe, in my first slide, it said April of 2014. Once that document's issued, it becomes effective. Now, did it get into play for the contract? Sometimes a contract will say the current edition at the time of contract, or if nothing is said about which revision, then the current one at the time of the contract is in play. Sometimes it's obscurely written, but basically change 1 is in force as of April, and we'll be seeing it called out very quickly. Some contracts will be seeing it that have been issued since then. So consider it to be in play, and also start thinking about the implications of the change.
Great. How is it possible to manage tailoring without a test plan?
Well, personally, I don't see how you can do it. I'd like to say that you can, but it's going to be difficult, and it's going to be subject to a lot of disapprovals and retests because we didn't satisfy the end user or the approving authorities' guidance on what they consider to be acceptable for that kind of product. You have to look at not just the, let's say, specific contract if you're looking for broad applications. So you as a manufacturer, although you might have a contract to supply a product for a ship, you may want to sell that into the airplane world too. So the Air Force and helicopters and etc., there's an applicability. So you may want to delve deeper into the development and testing to cover all these various tailoring options and having a worst case program so you get everything done at once instead of looking, okay, I satisfied this contract and then I got to go redevelop it for the next contract. That's not time efficient. The exception to that is when you're under contract that is funded by the contract, they're going to limit your scope of work to the contract requirements. They're not going to fund other activities for other sales. So you need to get that embodied into your contract if you're trying to get your product on a tri-service approval. Quite often those things come about and contract modifications happen that allows other agencies to come on board. That's the thing for your marketing and contracts people to work very aggressively.
Okay. Do your reports follow the outline presented?
I'd like to say yes. Generally they do. Some of the detail is left at bay. We work hard at getting these reports to be correct and have the detail called out here. Sometimes it's difficult because the program doesn't support the time necessary, or the anticipated results may not let us collect some of the data that we'd like to have after the fact. But in general, the photographs, the chart graphs are well used, especially to show the overall program. We could probably improve in some detailed information there. And clearly our results are dependent on the monitoring people. The customer that we're testing for does the monitoring, and they're somewhat less than stellar in providing the details of acceptance and etc. So sometimes we just issue the report because it's hard to figure out the detail. But truly that kind of an outline is our goal, and we target towards that aggressively. Anything else?
Great. We do have another question from the audience. Why is there no mention of synergistic effects?
The test procedure ought to consider that. Okay, it's not out of the question, but each one of the methods stand on their own as an independent item. Quite frankly, a lot of times we look at doing climatic work on a sequential or combined effects. One of the test methods, 520 I believe it is, does temperature, vibration, humidity, and altitude as one element and built around that. So they're looking at a lot of things happening together. Quite frankly, in the real world, these effects are there. And I have these events that show up. If I have a rain test without vibration and an item mounted on the outside of a vehicle, we'll kind of see that element. And does vibration cause gaps and seams to flex where the rubber gasket stays intact, but vibration causes it to leak? Well, the rain test may fail if it was done during vibration. Now, how do you get that to happen? How do you get rain going on your vibe table? Not very realistically. So we have trouble simulating some of these environments that the real world sees. So trying to combine things is a great thing, trying to be this overall test program. But in reality, the test program allows you to test. If you have 15 test methods, you can use 15 different test articles. It's not even required that the same serial number be used for all these tests. It doesn't make any sense to do it that way, because a reviewer ought to penalize you and criticize that, wait a minute, I'm not seeing the effects and the sequence of effects and the combined effects. So a good test program will take those into consideration, but we have to bring reality into being able to execute. I like to see it. I think it's a great program to combine those things, and I personally work very hard at getting this sequencing to happen so the residual effects or the contribution to the future is considered. Sometimes that's not always easy to do, but let's consider it and move it forward. I think that's a great thing. Maybe more work needs to be done in that area to build a test program, and a good procedure would make that happen. Hopefully that answered the question. Okay.
Great. Steve, thank you again for your time and expertise. Webinar attendees, if you have any more questions we didn't answer here, please send us an email at info@etdnews.com. A recording of this webinar will be available on our website, environmentaltestanddesign.com. We will also send a link to all participants shortly. Thank you for attending.